You know, I feel like we should have a skit for the intro of this video. Who is this we you're talking about? You know you're sitting in a room alone talking to yourself, right? Ah, come on, dude. Don't be like that. We're the team, the bros, the dynamic duo. Yeah, you might want to keep that to yourself, or people are going to start asking questions, and probably not in a good way. All right, so I'm really okay. Mostly okay. Look, I'm probably okay. But hey, I made a new friend during a quarantine. That's pretty cool, right? Dude, I'm not really here. That dude's always cracking me up. He's a funny guy. When it comes to your AWS bill, it can be pretty confusing. You know, everything's on demand, and like their billing system, whenever you first start with it, seems really overwhelming and confusing. I thought the best way to explain this to you is to just grab an AWS bill and we'll just go through it and look at the charges and see how they're broken down. So let's just jump in and take a look at a bill. So here's how I do this with my clients. Each client has a budget for AWS for each month. And so on the 15th of the month, we crack open the AWS bill and look at the charges up to date. And we expect those charges to be about half of what the monthly budget is going to be. And if it is, cool, we're all set. If it's more though, then we start digging into the charges to see where we're spending more money that we weren't expecting to. And we can decide at that point to either increase the budget or reduce costs and reduce services to bring the budget or the cost back in line with the budget. So let's just run through some stuff here. We're going to start off with the data transfer, and I'm not going to go through all of these. I'm going to go through just the ones that I think are going to be common and relevant to you. The first thing I look at whenever I get one of these bills opened up is everything is broken out by region, and I know where the services are operating for that particular client. So I look for any charges from regions where they aren't operating, because that to me is one of the early signs that the account may be compromised. You know, if someone compromises your AWS account, the first thing they're going to do is find out where all of your services are, and then they're going to go launch their services in a region where you're not operating, so that in your day-to-day activities you don't see a bunch of strange instances or strange services that you don't recognize. So first tip, make sure that you're only seeing charges for the regions where you're operating. So data transfer is one of these that's really confusing because you get data transfer charges between each particular region. And most of these are billed at zero cost. You know, transfers between the regions are either zero cost or very low cost. But what I look at in here are the amounts that are being transferred. For example, when I look at this bill, there was 83.5 gigabytes transferred from US East to Ireland. And I know for a fact that this particular AWS account doesn't have any resources in Ireland. So we've got to go take a look at this. Even though the charge is zero, why did we have 83 gigs of data transferring to Ireland? It doesn't make sense. So we're going to dig into that. A majority of your data transfer costs are going to come from this section, the bandwidth section. And bandwidth is broken out and billed on increments. So for your first, like the first X number of gigabytes is billed at one rate, and then there's another section billed out at a different rate, and then a higher tier usually, and it's based on, you know, giving you some cost savings the more you utilize a service. So we have data transfer in per month was 3,200 gigabytes, zero cost. The next section is our regional data transfer, and that's data transfer between different availability zones. So for example, if you've got an EC2 instance in one availability zone talking to a database in a different availability zone, that's going to be represented here in this charge. And we had just almost 16 gigs of data transfer there, billed out at 1 cent per gig, so it came out to $157. That seems pretty in line with our usage. And then we have our AWS or our Amazon S3 data transfer bandwidth, and this is broken down. The primary components here is data transfer out to outside of the US, Europe, or Japan, or transfer to within the US, Europe, or Japan. And for us, most of our activity here is within the US, and that's represented by the largest charge here. And again, the costs don't really add up to very much. In the final section, which represents the bulk of this particular section of the bill, is data transfer out, and that's really as simple as it seems like. It's just the data coming from your AWS account out to the internet. For example, when someone hits your website or your API and makes a request and you transfer that data out to them, that's what's reflected here. And it's broken down into two different billing increments. The first 10 terabytes is billed out at 9 cents per gigabyte, and then the next 40 terabytes is billed out at 8.5 cents per gigabyte, which makes forecasting this really hard. First of all, it's hard to know how much data transfer you're gonna have out. And second, when you try to do the math, you have to say, oh, okay, well, the first 10 terabytes are at this price, and then the next 40 are at this price, and then there's an additional tier beyond that. And the way that I usually approach this is to just, as the company starts to grow, make sure that these charges track in line or proportionally to the increased utilization of our application. The next section we're going to take a look at is Elastic Compute Cloud, which are your EC2 instances. Again, making sure that we're only seeing instances in the regions where we operate. So we've got data processed by the NAT gateways because we operate inside of VPC, meaning that our EC2 instances, the only access they have to the internet is going out through a NAT gateway. So this part makes sense. And then we've got the charges for the EC2 instances themselves, and that's broken down by instance type and the number of hours that those instances were running. So we had T2 Nanos running for 855 hours, T2 Micros for almost 3,000 hours, and so on for the different instances we have here. And so what you want to do here is just take a look at the costs, and sometimes it's helpful to count up the number of instances you had, multiply that by 24 hours in a day, and make sure that the number of hours here reflects that cost. And that's just helpful to make sure that you don't have instances that are running that you didn't know about. The other thing to look at is these are all on-demand charges. So if these are going to be instances that you're going to be keeping around for a long time, it's going to make sense to switch these from on-demand to reservations because you'll get a better price break by using a reserved instance than you do on on-demand instances. The EBS charges add up pretty quick. If you take a look here, we've got just almost $3,000 in EBS, which are the elastic block storage, the disks that we give to our EC2 instances, and the overall EC2 cost was $4,000. So it's a pretty fair chunk of it. Now you get charged for the bandwidth that you read and write to those block storage devices, but the bulk of your costs are going to come from provisioned storage. So if you provision 100 gigabytes for an EC2 instance, that's going to be the bulk of your costs. And what you want to do here is make sure that you're keeping your block storage sizes down to what's actually needed by that instance. It's tempting to over provision it, but you end up just paying for storage that you don't need. And it's relatively easy these days to increase the size of these block storage devices as you need to, so you don't pay for those charges until you actually need them. That's going to be kind of dependent though on you knowing when you're running out of space. So you want to go back to your application monitoring system and make sure that the disk space utilization is one of the metrics that you're tracking on your EC2 instances, and you've got alerts set off whenever those disks start to become full. I generally set a warning at 75% and an alert at 90% so that I'm well aware of which EC2 instances are potentially running out of disk space, and I can go take action before that disk fills up and crashes the server. The final part of this bill that we'll take a look at are the application load balancers. And it's kind of pricey. Like in terms of what you get for an application load balancer, it seems like a pretty reasonable charge for me. But you just want to keep an eye on this and make sure that this actually reflects the utilization and the load balancers that are active in your system. We'll take a look at the Elastic Container Service next, which is ECS Fargate. So if you're using Fargate for a Docker solution instead of EC2 instances to host your application, this is where you're going to see those charges. And this one, in my opinion, is actually one of the most straightforward billing sections in the AWS environment. I mean, we've simply got memory and CPU. Whenever you build your Fargate service, you tell it each container gets X amount of memory and X number of CPUs. You multiply that by the rate, and it's billed on an hourly basis. So to validate this, you just add up the number of memory that you're using in Fargate, multiply that by the billing rate, and that should come up with the number that you see here. And same thing with the number of vCPUs provisioned for your containers. If we take a look at ElastiCache, this one is pretty representative of some of the newer services you see with the managed services you see with AWS, because what you're doing with those services, we're using Redis here, and all we're doing here is launching EC2 instances with Redis pre-configured on them, and that's managed by AWS. So the billing reflects that. We've got a T2 micro, a T2 small, a T2 medium, and so on. And so the costs just reflect the cost of those underlying EC2 instances, plus a little bit added onto that to reflect the management of the Redis service in this case. And you'll see the same thing in the Elasticsearch service. Again, it's just EC2 instances that are pre-configured for the service that they are being used for. The key management service is kind of an interesting one. You get charged $1 per managed KMS key, so the billing is straightforward there. That can start to add up quickly though if you have a large number of keys. Again, it's a small portion of your overall AWS bill, but it's a good idea to keep track of this or keep tabs on it just to understand how many keys you are managing and make sure that that's in line with your expectations. The utilization of them gets billed separately, so you've got your first 20,000 requests are free, and then beyond that it's 3 cents per 10,000 requests. And this is another one where it's really, really hard to forecast exactly where this is going to fall if you're trying to budget for this. But again, the cost is low enough that it's not going to be a huge portion of your AWS bill. You just want to make sure that the actual numbers here align with what you would expect them to. For instance, in this one that we're looking at here, we used KMS keys to provide the application secrets. Whenever a container boots up, it contacts KMS, gets the secrets that are relevant to it, and pulls those into the application and uses them there. And we also use this in the development environment as well. So as a developer, whenever I boot up my development environment in the morning to get started for work, I don't want to run ElastiCache locally. So my application will contact KMS and it will get the credentials that I need to access a development environment of our ElastiCache service that I can use for developing locally. And so the local development access plus staging access plus the production access of every time we deploy or a container is recycled all adds up to the 3.7 million requests that you see here over the course of a month. So the RDS charges are going to look kind of crazy here, and there's some good learning to be taken away here. So the first thing we've got is the Aurora charges. We've first got the Aurora storage, which is billed here in terms of the number of gigabytes that you're storing each month and the cost per 1 million of I/O requests. And this is their database as a service thing, so you pay for the storage plus the access. And then there's the underlying instances that you pay for as well, just like we saw with the ElastiCache and the Elasticsearch. You're paying for EC2 instances pre-configured with the service that you want. Now the part that gets really interesting here is we've got the database service for Postgres, and we've got the database service for Postgres reserved instances. So reserved instances are a commitment from you saying we're going to use this database instance for the next year. And because that allows AWS to understand the utilization they're going to see, they can provision for that, and you get a price break for doing so. So it's well worth your time to take any of your long-lived instances and put them in reservations. And that doesn't mean that you have to keep that exact database around for a year. If you know that you're going to have an R4 4x large running for most of the year, put it in a reservation. And then if your database, if you change that database, you kill that one and launch another one to replace it, you still get that that reservation pricing, because the way that the billing works for reservations is the billing service says, oh, this person purchased 744 hours of a DB R4 4x large for the month. And if they see a DB R4 4x large running for that month, then they just credit your account with the reservation pricing versus the on-demand pricing. Now you pay for that up front, which is why you see the $0 charges here. But then we've also got some charges that are not $0 charges here. What that is they check this hourly, right? So let's say we purchased the equivalent of 3 running databases on reservations. Well, every hour they check, and if we've got 3 running databases, we're all cool. But if next hour they check and we had 4 of those databases running, we're going to pay for that 4th one using the on-demand prices. And so that's where you see these numbers coming in here, is we were running more DB-R4 4x large instances than what we had on reservations, which is totally fine. We just don't get the reservation instance pricing for that excess. We pay the on-demand pricing for it. Finally on here we see our provision storage, which, like we saw over in the EC2 instances, is a significant chunk of this bill. So you want to keep this provisioned pretty much to what you're utilizing. You know, give yourself a little bit of growth room, but you don't want to add hundreds of gigabytes or terabytes to this just in case. This is broken out into 2 different sections. There's the provisioned GP storage or GP2 storage for single AZ deployments and multi-AZ deployments. And the cost reflects that. If you've got a multi-AZ deployment, it means you've got a database instance running in 2 different availability zones. And that's why you see the price here double what it is for a single availability zone. The last one we're going to take a look at here is the Simple Storage Service, or S3. You might know them as the S3 buckets. And so we'll start down here towards the bottom with the timed storage byte hours. So the way that this works is you pay for the amount of data stored in your S3 buckets, and then it's broken up into 3 tiers. You know, you get your first 50 terabytes at one price, and then the next 450 terabytes is at a second price, a little bit cheaper. And then beyond 500 terabytes, you get the lowest price. So we've got just over 600 terabytes stored in S3 here, which is actually kind of funny because they said they deleted those videos, but it looks like they might have just shoved them in S3. But of the 600 terabytes of data stored in S3, you've got to ask yourself, how much of this are we actually using on a regular basis? Because you're paying for that. And what you can do is you can move that into infrequent access, meaning that you're not going to access it, so Amazon puts it someplace else and gives you a better price break for it. As a matter of fact, you can see the price break is around 2 cents per gigabyte here, but if you move it to S3 in frequent access, it drops down to just over 1 cent, and there's another 580 terabytes of data over there. So if you can move it to infrequent access because you're not going to be accessing it very frequently, you can cut your costs, your storage costs, in half over what you would pay for storing it in S3. The catch there brings us up to the top portion of this bill, is you do pay for pulling it back out of infrequent access. Now, it's not a huge cost. You can see that most of it here was pretty inexpensive, but you just do want to be aware that that cost does exist. The other section here that's worth noting is, again, you pay for transitioning it to infrequent access, but that cost is a pretty small percentage of what it would actually cost to keep it stored in S3. I think the biggest takeaway for you in this video is to probably set a calendar reminder on the 15th of the month just to check your AWS bill and make sure that it's tracking in line with what you're expecting that to be at the end of the month. Even if you don't have like a hard set in stone budget, just make sure that it's consistent with what it was for the previous months, or that it's tracking in line with some increased utilization that you have, to avoid getting surprised by a large bill at the end of the month. I've been hit with $50,000 AWS bills when I was expecting one to be around $10,000, and that's always tough to swallow. Now, when I first started using AWS like 10 years ago, you could contact them and let them know what you did, and they would sometimes forgive a portion of that bill. I don't know if they still do that anymore. I would rather see you set a calendar reminder and catch that before it becomes a problem, rather than relying on them to credit your bill if there is a problem. Because usually what happens is you either launch some really large EC2 instances and forget to shut them down, or you set up something that auto scales and it scales more than what you were expecting it to because you didn't put an upper cap on that auto scaling. Either way, it can lead to costs that you weren't expecting. One more thing that's worth pointing out when you're managing your AWS bill is the use of AWS tags. So in AWS, you can tag everything. And I use the format called insert to tag things. Insert is S-N-E-R-T. So we have N, which is the name of the resource, whatever you want to name it. The S stands for the service, which is the service that this thing belongs to, whether that's like your billing service or your customer profile service or your video streaming service, whatever piece it makes up a part of. E is for the environment, whether it's dev, staging, prod, test, or whatever. R is the role, is what role does this thing perform in its service. So if you have something like an RDS instance, obviously its role is going to be a database. Or if you have an EC2 instance, it could be a NAT gateway, or an application server, whatever type of function it's performing. And then the final tag is T, which stands for team. And the team is used if you have a question about this resource, don't know what it does, think it's misbehaving, want to justify the cost of it or whatever. The team tells you which team in your organization owns and is responsible for this resource that can answer questions about it. So when you use those tags, that also allows you to go over into the AWS Cost Explorer, which we didn't cover in this video because of how long it is already. But the AWS Cost Explorer allows you to look at your bill, and then you can break out the costs by these tags. So you can break them out by team or break them out by service and look at your costs that way and track your costs that way as well. So I'm a big fan of using tags for that purpose. The caveat there is go crazy with tags, but don't go too crazy with tags, because remember that every tag you create is a tag that has to be maintained. So when you're creating this tag, think about every time I touch this resource, am I going to be okay with going and updating the tag if it needs to be updated? Because once you cross that threshold where you have some tags that are accurate and valid and some that just aren't accurate or used anymore, you create this confusion across your entire tagging system that now you can't trust any of the tags, and then you've created just a situation that was worse than when you found it. So use tags, they'll help you out. Just make sure that you're using them diligently and the same across all of your AWS environment. If you found something in the video helpful, go ahead and click the like button for me down below, and be sure and hit subscribe also, so that when I release new videos each week, those show up in your feed. And that's all I got for now. So I'll see y'all next time.